Testing the sound, testing. Okay, today we're going to do unit conversions, what we once called factor label method in chemistry. Basic approach here is we start with a given measurement. We find a conversion factor to go to the base unit, and from the base unit we find another conversion factor to go to the final measurement. Before we can do this, we need to know the metric prefixes, and those are found in the first chapter of your textbook. They go from 10 to the 24th, which is iota, capital Y, all the way down to 10 to the negative 21st, which is zepto, little z. Deca and deci may not be in your table in your textbook, so you must add those on. Deca is 10 to the first, or 10, that's little da. Deci is 10 to the negative first, or 0.1, and that's little d. So you need to memorize the prefixes, the symbol, and the power of 10 that it represents. Let's do some examples here. Convert 60 centimeters to hectometers. Well, let's get to the base unit first, which is the meter. So we know that 1 meter is equal to 100 centimeters, so that's our conversion factor. We do the multiplication, we get 0.60 meters. Now we go from meters to hectometers, but we know 1 hectometer is 100 meters. We do the multiplication, we get 0.0060 hectometers. And once again, the problem is solved there. Convert 15 hectometers to centimeters. Get to the metric base unit of meter. That's 15 hectometers times the conversion factor 100 meters per 1 hectometer. That gives you 1,500 meters. Now to get to centimeters, use the conversion factor 100 centimeters per meter. And that now gives us 150,000 centimeters, or 1.5 times 10 to the 5th centimeters. Please notice that since I'm going from meters to centimeters, I want the meter on the bottom and the centimeters on the top so that the meters will cancel out, leaving just centimeters. Another problem. Let's convert 10 meters per second to some kilometers per hour. So we're dealing with speed here, or velocity. To do that, we'll get to the base unit. We've got to do 2 conversions now, one from meters to kilometers and one from seconds to hours. So let's start with the meters and go to the base unit, which is meters. We're already there, so we want to go to kilometers, so we'll say 1 kilometer per 1,000 meters. That's our conversion factor, and that gives us 0.01 kilometers per second. The meters cancel, leaving us with kilometers per second. Now to go from seconds to hours, we're going to say 3,600 seconds per 1 hour, and we multiply to 0.01 kilometers per second times 3,600 seconds per 1 hour, and that gives us 36 kilometers per hour. Okay. Next problem, convert 20 grams per cubic centimeter to kilograms per cubic meter. Once again, we have to do 2 conversions here, so let's do the grams to kilograms first. 1 kilogram per 1,000 grams. Do the multiplication, you get 0.02 kilograms per cubic centimeter. Now get rid of the cubic centimeters and go to cubic meters. So we know that there's 100 centimeters in 1 meter, but we're going to have to cube that conversion factor because we're talking about cubic centimeters, cc's, not just centimeters. And once we do that, we get ourselves 20,000 kilograms per cubic meter. So a density of 20 grams per cubic centimeter is equal to 20,000 kilograms per cubic meter. Now sometimes we go between the metric and the English system, and to do so we need to know these facts here. 2.54 centimeters equals 1 inch. 1 kilometer is about 0.62 miles. 1 newton, which is the metric unit for force, is equal to about 0.22 pounds. And 1,609 meters equals 1 mile, about. And one other useful fact is that there's 86,000 seconds in 1 day. So 86,000 seconds equals 1 day. We sometimes need to use those in our conversions from metric to English or English to metric. The final example here, 50 miles per hour to meters per second. So I'm going to get rid of the hours here first. So my conversion factor is 1 hour per 3,600 seconds. The hours cancel. When I do the math, it comes out to be 0.139 miles per second. Now we got to take care of the miles and get that to kilometers, or meters, excuse me. So 0.139 miles per second times 1,609 meters per 1 mile. That turns out to be about 224 meters per second. And all these problems, I have been giving the answer to 3 significant figures, I believe. We have to round our answers to the correct number of significant figures. We'll talk about that in class sometime shortly here. So tomorrow we will have a sheet to work on at the beginning of class dealing with these conversions here. If you need to, please review this video once again, and we'll see you in class tomorrow. Have a good evening.